Hello guys, today I have decided to make a video about limits in calculus which can be explained in a story mode that can understand even a 5-year-old kid. So it doesn't matter if you are a basic or beginner to all the way to advanced in mathematics. So it is simply a story mode which is explained by the calculus itself. So let's get back to it. So let's just imagine or assume that you are a geologist and a king said to find the height of the mountain that he has discovered. So what you do? You find the height of the mountain by climbing the mountain, etc. So here is the mountain as shown in the screen. So you have to be assumed that our mountain is perfectly symmetric. That means it doesn't matter if our adventure or we climb from the left side or from the right side. It doesn't matter. This is the same the both ways. So our first case, we have a straight line mountain. That means the peak of its mountain is straight, kind of like a plateau. So when we are slowly climbing towards it and we have finally reached its peak, we saw like a straight field. We have successfully reached the peak and we can easily find the height of the plateau itself. So you have to be understand that our mountain was a plateau, but our king hasn't told us what kind of mountain it is. It can be a plateau, a volcano, etc. So the king has said that there is a structure like that. So you are forced to say what's the height of this, but you don't know what it is, what kind of it is. But what if we look the other cases, like what if it was not a straight line, what if it was a normal hill like mountain? So it was a closed, but it was a curved shape, kind of like a normal hills. So if we have to find the height of the mountain, we have to go to its topmost peak. The peak must be a single exact point, right? So we have to find the height of that peak, that single point. If we go to the right, we have miscalculated. We go to the left, again we have miscalculated. So we have to go to that single point. So now, what if it was a crater, or what if it was a volcano? Which means that we are climbing the mountain, but the center of mountain peak was a little down. So which means at the peak the height was really low, and when we are climbing the height was very high. So the difference between them cannot be mismatched. So what do we say about the king? That the king told us to find the exact height, but we cannot say that the center was really deep but slope was high, which means that we are climbing, it was very high, but in the peak it was very low. So we cannot say the mismatch between them. We can only say one value. So how do we find a single value that can solve all the problems? So if it was a volcano, then we have no idea. Like we cannot stand on top of that, or we would just fall into it. So what would we do? Like if this was a crater, yeah, we could stand upon it and measure it, but it was not. It always will be low, less height compared to what we have climbed. So how do we fix this issue? So just understand that the slope we are climbing, that we know that rate. So we have been climbing them, so we understand, yeah, this might meet at a single point, and we can imagine, but it is actually not. So we cannot really go to the peak, but we assume that if we connect them with the dotted lines, we can say it meets at a point. Whenever we are climbing from the left or right, it doesn't matter, because we are climbing towards the same peak. But the fact that the peak is not there, but there is a crater or a volcano, so we assume that it joins at a single point. This is what it is all saying, that finding the limits means is to calculate like the height of the mountain, like the teacher as the king and students as we. So we have forced to say the height of the mountain, even though we have no idea what kind of function that is. So we have to study what it is actually. So what do? We take the dotted lines and then join them, and we say the height. So actually our mind creation, not an actual physical thing there. So we just connected the dots, like the slope from the left was same to the right, so they might converge. So we assume that, and you can see that it converges. So which means we have successfully find a single point, which is the y value or the height of the mountain assumed. And it also fails that is not the exact height, because there is a crater or the volcano is there. So we are assumed that it might be, if the volcano is in there, it might be joined at that single point. So we make the crater or the volcano to our plateau or the normal mountain. We converted that to say, yeah, this is the height. So the normal mountains can be represented, or simply we can take the measurement, but we cannot do that in volcano situations. We have to rebuild that into our known measurable quantities. So that is it. That's the limit. So the statement of the limit means that what is the height of the mountain if it approaches, or when we climb towards the peak, and if we can find the peak successfully very easily, then that's the limit or limiting value. Or if we found that our mountain was a volcano, we cannot go to its peak. So that is that we have to find other ways to measure it, like connecting the dots of the slopes, and we assume that it is our final mountain height, and we say that is the limit, or that is the single point that converges to our value, the height of the mountain. So that is it, that the limiting values or the limit concepts is simple as that.